8F.1 quantiles. Again, something we've done before, but we're going to look at some more challenging circumstances around it as well. Look, today I'm going to be very brief here, catch up with you guys, and then there's some stuff about normal distribution that I want to touch on, some different calculated techniques to talk about. Okay, so X is normally distributed, the mean is 30, the standard deviation is 5. Okay, and it says find this value of K such that the probability of X being larger than K is 0.23. So with all three of these examples, first I'm going to illustrate what that means. So here's our normal distribution. Our mean here is 30. Okay, so we've got 50% of the data this side, 50% that side. And we're saying the probability of X being larger than some number K is 0.23. So K is going to be here, the probability of X being larger than it. This area is 0.23. And so it says, using all that information, find this value of K. So when we do normal distribution calculations, we're doing the opposite, aren't we? We're given this value of K and we're told to find the probability. And so here we're given the probability, we're told to find this value of K. That makes it true for an event to be larger than K, the probability is 0.23. So on our calculator, that's an inverse normal calculation. So statistics, distribution, normal, inverse normal. That, dist, normal, and inverse normal. And then we look and we just go, our data should be variable. It's always the case for us, okay? It's never in the list. Our data should be variable. And then we look and we say, which way is the arrow pointing? Okay? So here the arrow is pointing to the right. And so where it says tail, we're going to press that so that it says right. Okay, so I'm going to list the calculations that I'm doing here. Tail should be right. The area, okay, that's the probability we're talking about, 0.23. We've got standard deviation, we've got mean. Okay, let's calculate that. And we've got K is 33.69. 33.7. Okay? So just to really answer this in the context of the question, what does it mean? It means given this variable, this mean, this standard deviation, the probability of X being larger than 33.7 is 0.23. Okay? If you perform that calculation, that it will be a probability. We're doing the opposite. We're starting with the probability and we're saying what's the number that makes it true. Okay? So to answer A, K is 33.7. Alright, so then let's move on to B. Okay, so B says find K such that the probability of X being less than K is 0.65. So K is actually going to be in a reasonably similar location because we know the probability of X being less than 30 is 0.5. So if we want to get to 0.65, we're going to have to go this way a little bit more. And now we're talking about this region. This region is 0.65, sorry, and this is K. And we're saying the probability of X being less than K, less than this value, is 0.65. Okay? So this time, our tail, if we look at our arrow, it's pointing to the left. Our area is 0.65. Standard deviation and mean remain the same. We follow the same calculator instructions. I'll put our answer up here. So we're changing the tail and we're changing the area. 0.65 for area. 31.92 or 31.9. Okay, so what does it mean in the context of the problem? It means the probability of X being less than 31.9 is 0.65. Okay, we're starting with the probability and then we're saying what's this number that makes that true. All right. What does that say? Anyone have that written there? What was this probability that I just rubbed out? 0.8 was it?
Yeah.
Thank you. Okay, so let's move on to C then. Now in C, it's saying, let me sketch the distribution so we can have a bit more of a look at it. I'll drop this out, clear that a bit. It's saying we've got the mean, which is 30, and then we've got the mean plus k. So we're going to have 30 plus k. All right, the mean plus k as the upper boundary, and the mean take k as the lower boundary. So 30 take k. And it's saying this probability is 0.8. Okay, we've got from the mean plus k, and then to the mean take k. This probability is 0.8. What is the value of k? Okay, well, it's symmetrical about the mean, isn't it? Okay, because we're going the same distance from 30 up and the same distance from 30 down. So our tail is central. Okay, tail central, area 0.8. Mean and standard deviation remain the same. Now, when we perform this calculation, I've got 23.59 or 23.6. I'll perform the rounding straight away. 23.6 here and 36.4 here. Wow. But we need to answer the question. What is the value of k? Find k such that this is true. Well, the mean plus k is 36.4 and the mean take k is 23.6. So, I mean, you can just look at it from there. The mean is 30. 30 plus k is 36.4. So therefore k is 6.4. All right? 30 take 6.4, 23.6. So we've identified the value of k for question C. K is 6.4. Cool. Excellent. So then let's move on to over here. This is probably as complex as this exercise will get. I will need my calculator. We've got some normal distribution, a mean of 50, a standard deviation of 10. And I will draw it up. It's indeed. Okay. And so mean is 50. And then we're saying so between 42 and A. Between 42 and A. Now I might just draw a few standard deviations up here as well. So the standard deviation is 10, so that's going to be 40. Then we have 30. Going up this way, we would have 60 and 70, etc. And now we're saying between 42 is going to be here somewhere, isn't it? That's going to be 42. And A. A is going to be somewhere larger than 42. We're not heap sure where it is, so it doesn't really matter for the purposes of the illustration, but I'm going to put it in there somewhere. Between 42 and A, this event here has a probability of 0.34. Okay, find the value of A. So what we're going to do here is we're going to combine a number of processes that we know. The first thing that we're going to do is we're going to say, well, given this variable, given all this information, what is the probability of x being less than 42? We're going to say, what is the probability of this event? I'm going to shade it in colours so we can see what's going on. Okay, so if we want to perform that calculation, that's a normal distribution calculation. We've got our lower boundary is minus infinity, our upper boundary is 42, standard deviation is 10, and the mean is 50. Okay, so we'll put that in. It's not an inverse normal, it's a normal distribution calculation, NCD, minus infinity, and 42, 10, 50. I've got 0.2118. 0.212. Okay, so look at this beautiful distribution. So now we've got the probability of the green is 0.212, and we've got the probability of the shaded black area is 0.34, which means, this is it, The probability of x being less than a, or being less than that value of a, is 0.34 plus 0.212. Probably is all of that added together, isn't it? Is 0.34 plus 0.212. And now we're up to the hills, what do we get there? 0.552. Okay? Because now we know exactly how to do that calculation. That's an inverse normal calculation. Our tail is left. The arrow is pointing to the left. Our area is 0.552. We've got our standard deviation is 10 and our mean is 50. Distribution, normal, inverse normal. Left. 552. 51.37. 51.307. 51.3. Okay, how could you check you got the right answer? If you put 51.3 here, you perform this calculation. 51.3. Okay, the probability of x being between 42 and 51.3, you'll get 0.34. Okay? So let's break that down. What do we have to do there? Well, first we calculated this event, okay, the probability of x being less than the lower boundary here. So then we could make a statement about a being completely under that. The probability of a being completely less than a being the sum of those two. Okay, so that's 8F.1. Are there any questions about any of this process up here? People sort of remember doing it a bit? Yeah, good. Okay, let's get into it.
I was sliding everywhere coming back.
Thank you for touching that up for me.